Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome back to Mr. Math Academy. So today in this video we'll discuss about the scalar multiplication and the matrix multiplication, how we can do, because in the previous videos we have done the matrix addition and the matrix subtraction. Now we'll go for the one more matrix operation, that is a scalar multiplication. Okay, what is a scalar multiplication means? Only thing is, if I take any one matrix here, so I need to add, means I need to multiply that matrix with any number or like constant here, whether it is possible or not. Okay, now if suppose if I take the matrix A is equal to some 2 3 4 5. Okay, if suppose if I take that this is a matrix A here, so I need to multiply with any constant here. So in that case, whether the matrix multiplication, how it will be. Okay, so I need to go for that one. If suppose I need to find out 3a, so means what? So this will be the matrix A is given, I need to multiply with 3. So this is given by, so this is 3 and the matrix A is 2 3 4 5. Okay, and this is the condition what we have to find out. If suppose this is the number here and this will be the matrix, so then how we have to multiply here? So means what? The whatever the very simple thing, the whatever the number has given, okay, that number has been multiplied to the all the elements of the matrix here. It means what? You just take 3 into 2, means for each elements of the matrix here multiply with 3 here. So this is given by, so that is 2 into 3, that number, this 3 into this number, so 4 into 3, again 5 into 3. So here we don't worry about the order of the matrix here, only thing is just multiply the number whatever he has given in with respect to the elements of each and every elements of the matrix here. Okay, we know that this is a simple thing. So this becomes 2 2 3 are 6, 3 3 are 9, so 4 3 are 12, again 5 3 are 15. So this is a matrix what we are getting, that is a and matrix multiplication, that is a scalar multiplication. Okay, in general if I take some k, okay, k into suppose a11, or suppose if I take a b c d. Okay, so if I take k is equal to some constant and the matrix is equal to some a b c d, these are the elements of the matrix. If suppose if I take, now what will be the scalar multiplication? So finally the matrix becomes, so just multiply this if suppose what I am taking the k is a constant, means this k you just multiply with all the elements of the matrix here. It becomes k into a, k b, k into c, and k into d. Okay, so this is the finally what is the matrix what we have to get here, means that will be the final matrix when we multiply with the constant k. Okay, it might be any number. Okay, it might be any number here. Okay, that gives the final matrix here. Okay, now this will be the scalar multiplication, means what? We need to multiply with the constant. Now we'll go for the last one, that is a matrix multiplication. So it is also quite simple, but the thing is, so when we do some multiplication we have to check the compatibility of the matrix here. So what is the compatibility now? That is important here. Now we'll go for the fourth one. This is last year. So this is a matrix multiplication. So matrix multiplication is possible only if the matrix A and B satisfy the compatibility condition. So if I take multiplication of matrices, okay, two matrices is possible only if it is satisfied compatibility, if it is satisfied the compatibility. So now we'll go for what is meant by compatibility with some example here. If suppose if I take some matrix 2 3 4 5, Okay, if I take the matrix like A, whatever the matrix A, 2 3 4 5, and again if I take one more matrix here, 5 6 7 8 9 and 4. So now we just go for the what is meant by compatibility here. Now for the matrix, this one matrix A, if suppose if I take this as a matrix A in general, for this matrix if I take this as a matrix B, so then what will be the matrix A into B? What will be the matrix A into B? That is the first one. Okay, now very first step is what we have to find out here. First we'll go for the what is the order of the matrix here, because when we are doing the matrix multiplication, the important thing is we need to find out what will be the order of the matrix here. So you can just see here 2 rows are there and 2 columns. So I'll just write 2 rows 2 columns, means 2 cross 2. Again for this 2 rows and 3 columns are there, so I can able to write the order is 2 cross 3. Okay, now to check for the compatibility, if it is compatible, means A and B are compatible, then only we can go for the matrix multiplication. This is a very first step here. Now I'll take, it's a 2 cross 2 matrix, that is a matrix 1. I have taken the order of the matrix A. I'll go for the matrix 2 here. Okay, so what we have to do here, I have taken, this is the order of a matrix A, so this is the order of the matrix B. Now the first number indicates it's a row here, so we know that this is a row. The second number indicates it's a column, so similarly this is a row, so this is a column, right? Now so when we are taking the orders of the matrix here, we have to compare the second and the third element here. Okay, we have to compare the second and third element. If it is equal, then only we can able to multiply the matrix. So if it is same, means it's a compatible, means PA matrix A is compatible with matrix B, means both the matrices are compatible. So these two must be same, that is the second and the third element. If it is same, then it is said to be compatible for a matrix multiplication. Okay, these two should be same. Now there is one more point you can remember with this. Okay, what will be the final matrix? So what will be the final matrix means, so what are the two, again what are the again two elements we have left here. You just see this is the first is there, and again the last one is there. So this 2 I'll write here, and again this 3 I'll write here. So this is a 2 cross 3, means what this 2 cross 3 indicates, it's a final order of the final matrix, that is order of the final matrix, that is a what I'm getting the after multiplication of the matrix A and matrix B. Okay, now this is satisfied now, because 2 cross 2 the first order here, so it is a 2 cross 3. So second and third element are same, so this satisfied the compatibility for matrix multiplication. Okay, now final order of the matrix will be the first and the third one, that is the first and the last one, that is 2 cross 3. Okay, now if it is satisfied, now the condition has been satisfied. Now the second step is what, now we'll go for the what will be the matrix multiplication, how we can go for the matrix multiplication now. Okay, I'll just go with the same matrix here. So important thing is, so simple here. So what we have to do here is, so now take this first row of the matrix A, multiply with first column element here. Okay, so what will be the final solution, that is a final order here, it's a 2 cross 3 matrix. I'll write the 2 cross 2 matrix here. Okay, so I'll write the 2 cross 3 matrix somewhere, it's a 2 cross 3. I'll write here, I need to get 2 rows and I need to get 3 columns here. Okay, so this is the final matrix. Now what are the positions here? So I'll just go for the positions here. So 2 cross 2 means, you can just see here, this is a 1 place, second and third place. Similarly, one more place here, second and third. So 2 rows and 3 columns should be there because the final order of the matrix here. Okay, now in this position, so what are the elements I have to write? So means what? Take the first row of the matrix A and first column of the matrix B. Okay, multiply and we have to add. Suppose for example like that, 2 into 5. I'll just take 2 into 5 plus we have to take 3 into 8. 3 into 8. Okay, this is the first position of the final matrix here. Again, so in this place the same row, that is the first row itself, because in the entire row we are just multiplying with the first row of the element A. Okay, now here in place of first row second column, take the first row second column of the matrix B here. So this second column of the matrix. Okay, now I'll go for the 2 into 6. I have to take here 2 into 6 plus 3 into 9. Similarly, so first row third column, first row third column. Okay, 2 into 7 plus 3 into 4. That gives the first row columns. Okay, now again take the second row, multiply column, each column and write in place of here. I'll go for this one now. 4, this is the second row, first column. So I'll write 4 into 5 plus 5 into 8. Okay, that is the first one. Now second row, second column. It should be in the position of second row, second column. Means in this place we have to write. So take 4 into 6. We have to take always, it's a plus 5 into 9. Okay, that completes the second position of the second row, second column. Again, second row, third column. Final matrix is second row, third column. Means in this position we have to take. That is 4 into 7 plus 5 into 4. Okay, now this is simple how we have to multiply. Take the first row, first column. So first row, first column means in this place we have to multiply and we have to add. That is the addition here. First row, second column. So first row, second column is in this position we have to simplify. First row, third column. So means the final solution will be first row, third column means in this position. So similarly we have to go for the second row, second column means all the elements here. Now the remaining things are same. Like remaining that is a simplification is very simple. So it is, we know that. So it is a 2 5 are 10 here plus 8 3 are 24. So this is a 2 6 2 are 12 plus 9 3 are 27. So 2 7 is 14 plus 4 4 3 are 12. Okay, I'll just take somewhere here itself rather than that side. So the remaining terms are very simple, just multiplication, simple thing. So I'll take 2 into 5 is 10. So plus 8 are 24. So 6 2 are 12 plus 9 3 are 27. So 2 7 are 14 plus 12, 3 4 are 12. Again for this 20, 4 5 are 20 plus 8 5 are 40. So again 4 to the 24. So this one is 45. 5 9s are 45. Again for this 28. 4 7 are 28 plus 5 4 are 20. Now you just simplify this. you can get a final matrix here, that is a 34. So this is 39. So this is 26. So this will become 60. So this is your 69. So this becomes 48. So this is your final matrix, what we are getting after the matrix multiplication here. I hope you are getting here. Now you just compare with the matrix, that is the order of the matrix, that is the final order of the matrix here. If it is getting this one 2 cross 3, then the solution is correct. You just here there are 2 rows and 3 columns, 1 2 3, 2 rows 3 columns. This is a matrix multiplication A into B. Okay, so this is how we can multiply the matrix here. But you just remember that matrix AB is always not equal to matrix B into A.